Hi class, we continue our study in the fundamentals by moving in and talking now about complex numbers. So I just have two quick objectives I want to do in this video. I want to talk about arithmetic operations on complex numbers, and then finally talk about square roots of negative numbers and get into a little bit solving equations that involve the square root of negative numbers. Okay, so first off, if the discriminant of a quadratic equation is negative, the equation has no real solutions. We say that it has two imaginary solutions. So for example, if you look at this equation, x squared plus 4 is equal to 0, it has no real solutions, because if you try to solve this equation, you'd subtract the 4 over, and then you take the square root to solve, and you get x is equal to plus or minus square root of negative 4. But we know this is impossible since the square root of any real number has to be positive. So for example, negative 2 squared is equal to 4 is a positive number. Okay, so thus negative numbers don't have real square roots. Okay, so to make this possible to solve all quadratic equations, mathematicians invented an expanded number system called the complex number systems. And first they define the new number we call I. And what I is equal to, it's equal to the square root of negative 1. Okay, think of I as the imaginary unit. Okay, what this means then is that I squared, if you were to square both sides, so whenever you see an I squared, it's the same thing as negative 1. So a complex number is then a number of this form a plus bi, where a and b are real numbers. Okay, so just a quick definition. The complex number is an expression of the form a plus bi, where a and b are real numbers, and I squared, the imaginary unit, the imaginary part, I squared, is equal to negative 1. So the real part of this complex number is a, and the imaginary part is that coefficient in front of the ib. So the complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. Okay, so note that both the real and imaginary parts of a complex number are both real numbers. Okay, that I there just tells me that's the imaginary unit, or the square root of negative 1. Okay, so the following examples are examples of complex numbers. So 3 plus 4i, the real part is 3, the imaginary part is 4. This one, 1/2 minus 2/3 I, the real part is 1/2, the imaginary part is minus 2/3. 6i, the real part is 0, all right, and the imaginary part is 6. And even if you look at the number negative 7, what we're saying here is the real part is negative 7 and the imaginary part of this is 0, okay, because 0 times I would still be 0. All right, so let's do some arithmetic operations on complex numbers real quick. So there's, I'm going to start with the addition, subtraction, and multiplication. Think of these when you go to do these about as combining like terms. So the addition part, a plus bi plus c plus di, well, you add the two real parts, a plus c, and you add the two imaginary parts, b plus d, and then those have the I, the imaginary unit there. Same deal with subtraction. This is just a minus c plus b minus di over here. Multiplication is a little bit more tricky, so you would actually FOIL this out. Okay, and when you FOIL this out, you'll notice that when you get to one part, you have this bi times di right here. Okay, bi times di would be b times d times I squared. Well, I squared is equal to negative 1, and that's how we have this negative sign right here. So it's just a times c minus b times d plus a times b, or excuse me, a times d plus b times c, and then times I. All right, let's just go through these real quick. So let's express all the following in the form a plus bi. So let's write this out as a complex number. So this first one here, okay, let's take 3 plus 5i and then add it to 4 minus 2i. Well, so according to the definition, we add the real parts, so 3 plus 4, and we add the imaginary parts, so 5 plus or 5 minus 2. And so our result is 7 plus 3i. That's it. Let's do the subtraction here. Same deal. You would get the real parts, 3 minus 4 here, and then 5 minus 2. So 5, minus 2 over here, and then the imaginary unit, I. And that just simplifies to minus 1 plus 7i. Here, when you FOIL this out, okay, remember that we talked about that I squared unit. So 3 times 4 goes here, and then minus 5 times minus 2, notice how I have that here, plus, now we're just doing 3 times minus 2, plus 5 times 4. And this just very simply simplifies to 22 plus 14i. All right, let's try this one here. Okay, it's a little bit harder. Okay, I to the 23rd power. Well, I know that I can rewrite that as I raised to the 22nd power plus 1. So just splitting it up, I can write this as I squared raised to the 11th power times I. Well, I squared is negative 1. Negative 1 to the 11th power, you see, is just negative 1. And then negative 1 times I is just negative I. So even something crazy like this, you can simplify using the rules of exponents that you know. All right, division's a little bit harder. Okay, so we use this property to divide complex numbers, the following one. So if you have to simplify the quotient a plus bi divided by c plus di, you multiply the numerator and denominator by the complex conjugate of the denominator. So all the complex conjugate is, if you have c plus di, its complex conjugate is just you change the middle term, it's c minus di. So you would FOIL the numerator. When you FOIL out the denominator, this is really important, okay? This c plus di times c minus di will always, always, always simplify to be c squared plus d squared. So the i's will automatically go away and you'll just be left with some real number, okay, which is great, which is what we want. All right, so let's do two examples here, okay? So let's do, first off, I want to figure out how to simplify 3 plus 5i divided by 1 minus 2i. And then we'll do one that looks a little bit weird, right? 7 plus 3i divided by 4i. All right, so the first one here, all right, you're going to multiply both the numerator and denominator by the complex conjugate of the denominator to make a new denominator that's a real number. So the complex conjugate of this, 1 minus 2i, would be 1 plus 2i. Okay, so that's what its complex conjugate is, 1 plus 2i. So therefore, when I do this, I'm going to multiply my original expression by both the numerator and denominator by the complex conjugate of the denominator. And when I do that, when I FOIL this out, I won't walk through it exactly in this video here, but when you FOIL out the top, you end up just getting minus 7 plus 11i. And remember here, this would be 1 squared plus 2 squared. Well, that would be 1 plus 4 gets me 5. And then here, I'm just going to split it up so that I can see what the real part is. The real part is that minus 7 fifths, and the imaginary part would be that 11 fifths. And that's how you would solve that problem right there. This one here, when I look back at this problem here, okay, oops, sorry. Right here, the complex conjugate of 4i is just minus 4i. Okay, so what I'm going to do, notice I just changed the sign there, okay? So I'm going to multiply 4i through everything here. Well, minus 4i times 7 gets me minus 28i. Now this is important. Minus 4 times 3 gets me minus 12, but then I times I gets me I squared, which is negative 1, which gives me that positive 12. 4 times negative 4 is minus 16. I times I is I squared, which is negative 1. Negative 1 times negative 16 gets me that positive 16 there. Splitting these fractions apart, I get 12 over 16, which is just 3/4, minus 28 over 16, which is just 7/4 I. So that's great. All right. Now let's talk about square roots of negative numbers here, and specifically how we're going to use it to help us solve equations. All right, so if r is negative, then the principal square root of negative r is the following. If I take the square root of negative r, anytime you have a negative underneath a radical, you can just factor it out as an I, because really what this becomes is negative 1 times r, and then the square root of negative 1 we know is just I. So the two square roots of negative r are I is the square root of r and negative I square root of r. Because remember, when you take the square root to solve, you get two solutions, one positive, one negative. All right, so we usually write these values with the I in front, so I square root of b instead of square root of bi, just to avoid any confusion that is the I underneath the square root. So always put the I in front. Okay, so this one here, square root of negative 1. Factor out a negative as an I. So this is just I square root of 1. All right, square root of 1 is 1, so it's just I times 1, which is just I. Okay, which makes sense because that's how we've defined the square root of negative 1. Square root of negative 16, negative underneath the radical comes out as an I. Square root of 16 is just 4, so this just simplified to 4i. This one here, square root of negative 3, negative underneath the radical comes out as an I, and this is just I times the square root of 3. Okay, and that's just simplified, can't go any further. All right, so let's solve these equations next. All right, so this x squared plus 9 is equal to 0, and then this x squared plus 4x plus 5 is equal to 0. All right, so this one here, so the equation here, going back, sorry, the equation x squared plus 9 equals 0. To solve this, subtract the 9 over, so we get x squared is equal to negative 9. So when you take the square root to solve, you get x is equal to plus or minus the square root of negative 9. Well, negative underneath the radical comes out as an I, and then, well, what's the square root of 9? 3. Okay, so therefore what we say is we have two imaginary solutions, and those solutions are 3i and minus 3i, right there. All right, let's do this one here. Going back, here you're going to have to solve this by the quadratic formula. Okay, so plugging it in, going back, my value of a is 1, my value of b is 4, and my value of c is 5. So plugging that into the quadratic formula, you get the following, which will just simplify to minus 4 plus or minus the square root of negative 4 divided by 2. Well, square root of negative 4, well, the negative comes out as an I, and the square root of 4 is 2. Just dividing everything by 2 here, you see you got, the solutions are negative 2 plus or minus I. So there are two solutions here, okay? 2 plus I and minus 2 minus I. Okay, and that's okay when you solve these problems to get an imaginary or a complex solution. That's okay.